To change £50 to yen, we first need to go from pounds to euros, £1, 1.2 euros, and then from euros to yen. So if £1 is 1.2 euros and we have £50, well, if I times by 50, £1 times 50 is £50, therefore times 1.2 euros by 50, 1.2 times 50 is 60 euros. Then using the exchange rate, 1 euro is 120 yen. I've got not 1 euro but 60 euros. So 120 times 60 gives me 7,200 yen. Question 2, I'd suggest carefully type both parts A and B into your calculator and then write down the solutions. Part B, you get full marks if you write 3, but remember when you square root a number you get plus and minus of the solution. So square root of 9 is plus and minus 3. In order to factorise 14x minus 35 we need to find a common factor. Common factor of 14 and 35 is 7. 7 times 2x would give me 14x. 7 times minus 35 would give me, 7 times minus 5 would give me minus 35. So in factorised form, 7 brackets 2x minus 5. Part B, in order to expand and simplify, I need to multiply out each of the brackets. 3 times the 2c, 6c, 3 times minus 5, minus 15, minus 2 times c is minus 2c, negative 2 times negative 4, negative times negative positive, 2 times 4, 8, 4c minus 2c, 6c minus 2c is 4c, minus 15 plus 8, minus 7. With indices outside of a bracket, we need to square, in this case, because it's power 2, square everything inside the bracket. So the 4 needs squaring, giving me 16, and the e to the power of 3 needs squaring. With brackets, I multiply the powers. 3 times 2, 6. So 16 e to the power of 6. Expand and simplify. So expanding out the brackets, FOIL, or kind of claw, however you remember it. A times 2a gives me 2a squared. A times minus 1 is minus a. 5 times 2a, 10a. 5 times minus 1 is minus 5. Minus a plus 10a, 9a, or 10 minus a, 9a. So final answer, 2a squared plus 9a minus 5. In order to work out the total area of this shape, I'd suggest you split it into multiple parts. We've got this triangle, we've got the front triangle, and we've got the rectangle. So thinking about each of those parts individually, if I take the rectangle and add on the front triangle, I'd need to take away this rear triangle to give me the total area. So that's what I've done in the working below. So the rectangle, 12 centimeters by 15 centimeters, 12 times 15, 180. Front triangle is going to be that width there, 12 times 10, and we want half of that because it's a triangle, half base times height. So 12 times 10 times a half, that's the front triangle. And then we've got this other triangle, base 12, height 4, half base times height, half times 12 times 4, 24. We're doing this rectangle plus this front big triangle, take away this smaller triangle here. 180 minus 24 plus 60, which equals 116 centimeters squared. Find the probability that the bead is yellow or blue. Well, in probability, if I'm finding the probability that something is one thing or another, I add the probabilities together. So probability of yellow, 0.08, probability of blue, 0.25. Adding those together, 0.33. Find the probability that the bead is neither yellow nor pink. Well, the probability of picking a yellow or a pink, 0.08 plus 0.1, remember or plus, which gives me a solution 0.18. If I want not yellow or pink, well actually that's the same as 1 minus the probability of picking yellow or pink. So 1 minus 0.18, which equals 0.82. Ajit replaces the first bead in the jar. He then takes at random a second bead from the jar. Find the probability that the first bead is yellow and the second bead is blue. Well, if he replaces the bead back in the jar, actually the probability hasn't changed when I pick my second bead. So probability of yellow and then probability of picking blue, and rather than or, probability and means multiply. So probability of picking yellow 0.08 multiplied by 0.25, which equals 0.02. Second jar contains 100 colour beads, of which 20 are brown, so 20 out of 100 of the beads are brown, i.e. the probability of picking a brown bead, 20 over 100, 2 over 10, 1 over 5. If we wanted to work out the expected frequency, i.e. the number of times we expect to pick a brown bead if we pick 60 beads from the jar, well, if the probability of picking a brown bead is a fifth, and we are picking 60 beads, we'd expect a fifth of those 60 beads to be brown beads, i.e. 60 times a fifth, which equals 12. Multiplying out the brackets, 4 times 5y, 20y, 4 times minus 1, minus 4, 3 times 3y, 18y, 3 times 7, 21. Moving the y's onto one side, well I've got more on the left hand side, so let's move them all to the left hand side. So taking away 18y from both sides, that would cancel out the number of y's on the right hand side. 20y minus 18y leaves me with 2y. Bring down the minus 4 and the 21. To get rid of the minus 4, if I add 4 to both sides, i.e. 2y equals 25. Now to get rid of the times 2, I must divide by 2. We'll do that on the other side as well. So 25 divided by 2, which equals 12.5. So in order to work out the percentage increase or percentage decrease, I need to look at the change divided by the original times 100. And that will give me the percentage change. The change in mine, well, he's gone from being 125 centimetres to 153, so he's grown 28 centimetres. His original height was 125 centimetres, so 28 divided by 125 times 100 leaves me with 22.4%. So Eloy, height at 12, 153 centimetres. His height at 20, I'm going to call a height h. Now I know that at 12 years old, he is 85% of his full height, i.e. 85% of the full height, h times 85%, equals his height at 12 years, 153 centimetres. 85% or 0.85, so to get rid of times 0.85, divide by 0.85 on both sides, 153 divided by 0.585 equals 180 centimetres. Now in order to calculate the length AD, if I look at this triangle here, triangle 1510 AD, redraw that, 1510 AD, I've got a right angled triangle, longest length C, other two lengths A and B. Pythagoras' theorem tells me that A squared plus B squared equals C squared. So A value squared plus this length here, 10 squared equals 15 squared, the longest length. Therefore, to get rid of the plus 10 squared, I must minus 10 squared. A squared equals 15 squared minus 10 squared. 15 squared minus 10 squared on your calculator is 125. A squared equals 125. In order to get rid of the square, I must square root. Square rooting 125 gives me 11.18, which to three significant figures is 11.2. In order to calculate the angle BCD, I need to think about this triangle here. So if I redraw that, so redrawing the triangle, length 10, 12.5, and the angle here that I want, BCD. So labelling this triangle, well, opposite the angle, so the side I label as the opposite, adjacent between the angle and 90 degrees, hypotenuse always the longest length, which is opposite the 90 degrees. Circle what you know. You know this length 10, you know this length 12.5. Therefore, opposite and adjacent, the formula that links those two is tan, TOA. Tan theta equals opposite over adjacent. Tan theta equals 10 over 12.5. To get tan to the other side, I must inverse the function of tan, so shift tan on your calculator, or tan minus 1, brackets 10 over 12.5, which equals 38.659, so one decimal place, 38.7. There are two ways you can calculate the sum of the interior angles of a polygon with 7 sides. First way, we could just draw a 7-sided polygon, and from one of the corners, cut it up into triangles. So from that one corner, go to every other corner. There I've got 5 triangles. I know there are 180 degrees in each triangle. 5 times 180 is 900 degrees. Alternatively, use the formula. Sum of interior angles of an n-sided polygon, 180 times n, which is the number of sides, minus 2. 180 times 7 minus 2, 7 minus 2 is 5. 180 times 5, 900. Okay, so here is my regular 7-sided polygon. To work out the interior angle, well, I know the sum of the interior angles is 900, so divide by the number of sides, 7, or the number of angles in each corner, which there are 7. 900 divided by 7 leaves me with the interior angle, this one here. Now, looking at my diagram, this point here is the interior angle, 900 divided by 7. With this angle being x. Now, if it's a regular polygon, which it says it is, then actually I know this side length and this side length are the same length. So this triangle is isosceles, so this angle here is also x. I've redrawn the triangle here, so I know that the side lengths are the same length, angles in each corner are x. I know this interior angle, 900 divided by 7, 180 degrees in a triangle, so 180 equals this angle, 900 divided by 7, plus x, or plus 2x. Taking away 900 over 7 from 180, and then dividing by 2, because I've got 2 times x, that'll give me the angle at the corner x, which is 25.7 to 1 decimal place. In order to find the gradient of a line, I need to rearrange my equation into this form, y equals mx plus c. The m value in the general form is the gradient, c value being the y-intercept. So rearranging my equation, well, if I add 2x to both sides, leaving me with just 3y on the left-hand side, 6 plus 2x on the right-hand side, 3 times y, so to get rid of the times 3, I must divide by 3. On both sides, so I need to divide everything on the right-hand side by 3. 6 divided by 3 leaves me with 2. 2 divided by 3 is 2/3. So I've got y equals 2 plus 2/3 x, or equivalently I could write that as y equals 2/3 x plus 2. So therefore, this value here in front of the x, 2/3, is my gradient, the value in front of x, 2/3, so gradient 2/3. If I want to calculate the equation of the line with gradient minus 3 that passes through the point 2,5, well, I know it must be this form, y equals mx plus c. The gradient, they've told me, minus 3. So that's my m value. So y equals minus 3x plus c. I don't know the c value currently, the point it goes through, but I do know the point that it crosses the y-axis, but I do know a point that it goes through, the point 2,5. So when x is 2, y equals 5, so I can substitute those points in. Minus 3 times 2 is minus 6. To get rid of minus 6, add 6 to both sides, so c equals 11. Therefore, the equation of my straight line that has gradient minus 3 passes through the point 2,5, so y equals minus 3x plus 11. Find the highest common factor of 3, 7, 80 and 3, 2, 40. Now they've done some of the work for you. They've expressed 3, 7, 80 and 3, 2, 40 as the product of its prime factors. If you want, you can write out 2 squared times 3 cubed times 5 times 7 as 2 times 2 times 3 times 3 times 3 times 5 times 7, etc. And the same for 3, 2, 40. In which case, you can now, I'd suggest the easiest way in terms of finding highest common factor and lowest common multiple is to put it into a Venn diagram. 2 circles overlapping, 3, 7, 80, 3, 2, 40. Right in the middle, what is common to both 3, 2, 40 and 3, 7, 80. So what factors are common to both? So if we look at our equation, well, common to both, I've got 2 2's. I've then got 3 3's. That's common to both. And I've got a 5. So I write those in the centre. They're the factors that are common to both. 3, 7, 80 I've got left over to write to 7. So I write that in this left-hand circle. And I've got left for 3, 2, 40 a 2 and a 3. So I wrote those in the right-hand circle. The highest common factor is all the numbers in the centre multiplied together. So 2 times 2 times 3 times 3 times 3 times 5. Now they want you to leave your answer as the product of prime factors. So leave it as 2 times 2 times 3 times 3 times 3 times 5, or 2 squared times 3 squared times 5. Sorry, times 3 cubed times 5.